So you just had some really great conversations with your partner. Let's say that you have three fractions that are greater than one half, but less than one. What can you say about the sum of those fractions if you add them together? Sometimes it's easier to work with an example, so here's an example. What if I wanted to add 5/6 plus 3/5 plus 7/10? Those are all bigger than one half. Those are all less than one. What if I wanted to estimate my sum? How small could it possibly be? How big could it possibly be? I could use the estimation strategy I used earlier. 5/6 is close to 1. 3/5 is close to 1/2. What about 7/10? It's a little bit closer to 1/2 than it is to 1, but it's kind of right in the middle. I guess I'll just use 1/2. But I know that really that's almost like halfway between 1/2 and 1. So my estimate is 2. And my real answer is probably pretty close to 2. I'm not sure. I'd have to do the math if I wanted to know the exact answer. This is a specific example. Sometimes when you're solving a problem, a specific example can help. Now let's see if we can generalize. So all of my values, all three of them are going to be greater than 1/2, but less than 1. Let me get rid of this example and just set it aside for a minute. What if instead of choosing three numbers like that, I chose 1/2 three times? It's not really allowed to choose 1/2 because I need numbers greater than 1/2, but this will at least give me a lower bound for my answer. 1/2 plus 1/2 plus 1/2. Let's see. 1/2 plus 1/2 is 1. And 1 plus 1/2 is 1.5. What does that mean? That means my sum must be greater than 1/2, than 1 and 1/2. My sum must be greater than 1 and 1/2. Because each of my three fractions has to be bigger than 1/2. When I add them together, I must get a sum that's at least a little bit bigger than 1.5. Well, how big could my sum be? What if I chose 1 for all three of my numbers and did 1 plus 1 plus 1? Well, I'm not allowed to do that. I can only choose numbers that are less than 1, but that would be 3. So that means that my sum must be less than 3. So I can now make a general statement. I can say that my sum must be greater than 1/2 and it must be less than 3 if I add three fractions that are greater than 1/2 but less than 1. This was kind of an abstract problem, and the way I approached it was first by looking at a specific example, and then by saying, well, what's the smallest it could be? What's the biggest it could be? What could happen? That's the strategy I used. Now, I want you to work with a partner to think about this one. What if two fractions, let me highlight that two fractions that are less than 1/2 but greater than 0 are added together? What can you say about their sum? Pause the video and talk. Let's change this. We don't want to talk for 1 minute. We want to talk for at least 3 minutes with a partner. And then hit play when you're ready to talk about what you talked about with your partner. You're ready to hit play. Hopefully that means you have some good ideas and that you're having a good conversation. Maybe it means that you're stuck. If you are stuck, here's a great place to start. You could think about how small could my answer possibly be? Start by adding 0 plus 0 because you know both these fractions are greater than 0. And then ask yourself, how big could it possibly be? To figure that out, try adding 1/2 plus 1/2. The value of your sum has got to be between these two sums. It's got to be between those two. So hopefully that makes sense. Did you think about it another way? If you had another way that you thought about this problem, share it with the class now. Pause the video and take a minute to talk about it. Hit play when you're ready for the last problem. So our last problem that we're going to look at today with our partner is similar to the last two. This time we have 7 fractions that are slightly less than 1. What can you say about their sum? We did a problem like this a little bit earlier, didn't we? Talk with your partner, figure it out, hit pause, and then hit play when you're ready to do our last task of the day. It's a group activity. Excellent job working with your partner. So here is our group activity for today. It is a demonstration of learning and it is called Copycat. Here's what it is. The teacher asked each of her students to create a rectangular design and shade only a portion of their design. The table describes 3 students' designs. Lily left 1/4 unshaded. Here's Lily's design. See, one of her 4 rectangles is not shaded. So that's Lily's. Emma left 2/5 unshaded. Here's Emma's. And then Molly left 3/12 unshaded. Here's Molly's design. Now, here's your task. Here's what you're going to do with these designs. Well, what happened is when the students saw each other's design, Lily accused Molly of being a copycat. Molly replied that she did no such thing and that Lily must be confused, as usual. Molly said her design was bigger than Lily's and was not even the same shape. Emma said she's staying out of this argument and she wouldn't take Lily or Molly's side. Well, here's the question for you. What do you think? Do you think that Molly, she's in green, copied Lily's design? She's in orange. Did Molly copy Lily? Why would Lily accuse Molly of copying her design? What do you think? So as a group, you want to think about that and see if you can understand that explanation. Choose a side and then write down what you think. Now, the next thing is that Molly thought her design contained the largest portion of parts not shaded. Why does Molly think that? Do you agree with her? I want you to talk about that with the group, and as a group, come up with an answer. Then each person will write their answer to both of these questions in their book. I hope you enjoy this activity, and I can't wait to hear the discussions that you have.